Hello everyone, we will be looking at the July 2021 CSEC Past-Paper-2 in mathematics. We will be providing a step-by-step solution to each problem, and in addition, we will give you some tips on what to look for when solving similar problems going forward. Now, in order for you to follow along with us, you will need to have a copy of the past paper. So let us get started. The first question is actually a fractions question, and if you notice, the examiners are merely testing whether you understand which operations should be done first. So in this case, I'm seeing two operations, a division and a subtraction operation. The examiners are expecting that you should know that you should perform multiplication and division before you do addition or subtraction. So let us just highlight this area, which is the section we're going to do first, which is the division section. So let's proceed. So first we convert to improper fraction and we get 11 over 7 divided by 2 over 3, which is the same as 11 over 7 multiplied by 3 over 2. I'm inverting and multiplying, and that works out to be 33 over 14. And that is the first part of this operation. The second part is the subtraction. So let's proceed to subtract 1 and 5/7 from 33 over 14. So let's once again convert this into an improper fraction. So it would be 12 over 7. And if I quickly change so that both fractions have the same denominator, I could multiply the denominator and the numerator of this one by 2. And that will become 33 over 14 minus 24 over 14, which is equal to 9 over 14. Okay, so this is our first question. Let's move on to 1B. Okay, so in 1B, Megan's weekly starting salary is $85, and after a 6-month probation, she gets a 20% increase. So her increase is going to be 20% of $85, which is 20 over 100 times 85, which is equal to $17. She was receiving $85 before, so her final salary is 85 plus 17, which is $102. So her final salary after an increase is $102. The questions are pretty straightforward, just enough to get you started, because this is usually a very tense time for students. So the examiners are deliberately trying to calm you down with really straightforward questions. It gets more interesting as we go forward, so please stay with us and pay attention. Okay, so for 1C, here we have a country A with a population of 2.714 million in 1965. In 2015, that population is 3.6639 million. So the first question, 1A, is asking to write the population in 2015 to 3 significant figures. So I look at the 2015 population and I see 1, 2, 3, 4, 5 significant figures. I only need 3. So I'm going to go to the 4th digit. It is less than 5. So I'll change that to a 0 and write as 3, 6, 6, 0 and 3 zeros. So that is really 3.66 million to 3 significant figures. Next, we're asked to write the population in 1965 in standard form. This would be 2.714 times 10 to the 6. All significant digits are to be included. Finally, we're asked for the population increase as a percentage. So let us first find the increase as a number. So that would be equal to 3,663,900 subtract 2,714,000, and the increase is 949,900. So that's 949,900. So as a percentage increase, that would be equal to 949,900 over the 1965 population. So that's 2.714 million. We multiply by 100 to convert to percentage, and that would be equal to 35%. Okay, so in 1D, we're given that the ratio of teachers to male students and to female students is 3 to 17 to 18. What we're told afterwards is that there are 630 students. So based on that ratio, how many teachers are in the school? So we're asked to compare teachers with all students. So we could actually compute the ratio of all students, 17 plus 18, and that would give us 35. So the new ratio is 3 to 35. So we can now calculate the number of teachers. So the number of teachers we call as x, then x over 3 is equal to 630 over 35. Let's write it down. X over 3 is equal to 630 over 35. We could form that equation. And by simply transposing, by first cross multiplying, we get 35 times x is equal to 3 times 630, and x works out to be 54 teachers. Moving on to question number 2, we're given that n is equal to the square root of t. So if t is equal to 49, what is n? Well, clearly n would be equal to the square root of 49. That is equal to plus or minus 7. That's the first part of the question. The second part of the question is asking us to transpose for t. So if n is equal to square root of t, then n squared is equal to t. So let's move on to 2b. So here we have 3 persons named Ali, we have Jim, and we have Chris. If Ali's age is taken today as x, we're told that Jim is 5 years older than Ali, so Jim would be x plus 5. And we're also told that Chris is twice as old as Ali, so Chris would be 2x. So in 2 years' time, the product of Ali's age and Chris's age will be the same as the square of Jim's current age. So Jim is now x plus 5, and in 2 years' time, Ali will be x plus 2 years. Chris will be 2x plus 2 years. And we are going to form an equation to relate the change with Jim's current age. So they're telling us that Ali's age in 2 years' time multiplied by Chris's age in 2 years' time will be equal to Jim's present age squared. So Jim is currently at x plus 5 squared. Ali's age in 2 years' time is going to be x plus 2. And it's a product, so we're multiplying by Chris's age in 2 years' time, which is 2x plus 2. And that should be equal to Jim's current age all squared. So what we need to do is to simplify this equation. So let's proceed to do that. So let us distribute x, and we'll also distribute 2. So let's start with x. So we have x times 2x is 2x squared, and x times 2 is 2x, plus, let's distribute this 2. 2 times 2x is equal to 4x plus 4. And that is equal to expanding this bracket. I'm expecting that you know how to expand the square bracket. So it's going to be x squared plus 10x plus 25. Now let us simplify the left side. This would be 2x squared. And we could add these two, plus 6x plus 4 is equal to x squared plus 10x plus 25. Let's take all of this to the left of the equation. So we'll have 2x squared plus 6x plus 4, and we're going to subtract x squared minus 10x minus 25 is equal to 0. So let's simplify. 2x squared minus x squared is 1x squared. 6x minus 10x is negative 4x. And plus 4 minus 25 is negative 21, and that is equal to 0. So after simplification, we have x squared minus 4x minus 21 is equal to 0. So part 3 is as follows. We should calculate Ali's present age. So in essence, we're being asked to solve the quadratic equation. So the equation is x squared minus 4x minus 21 is equal to 0. There are several ways to do this, but we could use the simple factorization method, which is to use two brackets and realize that x minus 7, x plus 3 would be the factors for this simple quadratic equation. So our answer would be either x is equal to plus 7 or x is equal to negative 3. We will ignore this answer because age cannot be negative. Okay, let's move along to the next question. Okay, so here we have a right angle triangle and this angle is 90 degrees. So the first question is to find the angle, which I will call theta, which is this angle. Well, of course, we know that all three angles should add to 180. So we could say 180 degrees must be equal to this angle we're trying to find, plus 90 degrees, plus 62 degrees. Therefore, the angle theta must be equal to 28 degrees. So write that here. Next, we are asked to find the length of a side, and this is this side. Let's call it x. So we could use the sine ratio, since we know that sine of 62 degrees, which is this angle here, is opposite, which is x over the hypotenuse, which is given as 11 centimeters. So we could write that here. Therefore, x, which is equal to 11 multiplied by the sine of 62 degrees, and that works out to be 9.71 centimeters. Okay, so part 3b of the question is a transformation question, and what we have are three triangles x, y, and z, and the first part of the question is asking you to state the equation of the mirror line given that triangle x is mapped onto triangle z. So we know that the mirror line is the halfway point between the object and the image. X is the object, y is the image, so that falls on the x-axis. So let's draw the mirror line. So here is the mirror line I've drawn here in green, and the equation of the mirror line is the x-axis, and the equation of the x-axis is y is equal to 0. So that is your equation. Now the second part of the question reads as follows: describe fully the transformation which maps triangle x onto triangle z. So we're mapping this triangle x onto z. We can see clearly that it is rotated in an anti-clockwise direction, and the rotation is 90 degrees, and the center of rotation is the origin. So the full description of the transformation that maps x onto z is an anti-clockwise rotation of 90 degrees about the origin. Part 3 of the question reads as follows: translate triangle y using a vector -7 and 1. What is that saying? Determine the coordinates of the image of y after it has been translated by a vector -7 and 1. So let's label the vertices of y. Let's call this r, s, and t. So we need to find r prime, t prime, and s prime. So we know that y prime is the translation of the object triangle y by a vector -7 and 1. So each point on y will move by -7, -1. So r will move graphically 1, 2, 3, 4, 5, 6, 7, and we move up by 1. So this is r prime. T will move 7 units to the left and up by 1. So t prime will move to this location, and s will move 7 units to the left, 1, 2, 3, 4, 5, 6, 7, and up by 1. So this is a new location of s prime. We connect those points to form our image triangle. So there we have it, our image triangle that we shall name V. Now we go on to part 4 of the question, and part 4 of the question reads as follows. Enlarge triangle X. This is triangle X. So we should enlarge triangle X about the center C. So we have the center C, and it happens to be the origin. So let's write that information down. So we have the center of enlargement C at the origin 0, 0. And we have the scale factor, also called the enlargement factor, we shall name as K, which is equal to a half. So we should reproduce the image after enlargement. So let us label the vertices of our object. Let's call this one as A, B, and C. So what we're asked to find are A prime, B prime, and C prime. So how do we find these new coordinates, or the coordinates of this image? Well, let us remind ourselves that from O to A prime divided by O to A is equal to our scale factor. Similarly, O to B prime over OB is also equal to our scale factor, and O to C prime over OC is also equal to our scale factor, which we know to be equal to half. So if we look at just one example, O to A prime is therefore equal to K times O to A, or let's write as a half of OA. What is that saying to us? It's saying that if we draw a line from the origin to the point A, then the image point will be located at the midpoint of that line. So let us draw a line from O to A so we could see what we're doing. So here we have a green line that we have drawn from O to A being the object point, and we know that the image distance is located at half the distance of OA. So half OA will be at this point. So this would identify our first image coordinate. Let's continue. Let's first draw a line between O and B. And if this represents OB, then we know that O to B prime is halfway along this line. So it's located exactly at the halfway point. So that would be here. So this would be B prime. Similarly for C, we draw the line between O and C, and we know that C prime is located exactly at the halfway point. Therefore, let's identify that point as here. We'll label that as C prime. And now we can complete our image triangle. And there we have it. A prime, B prime, and C prime. We connect the vertices to form our image triangle, which I'll be shading here. And we will label this one W. Okay, so let us move on to the next question. So what we're shown here are two lines L1 and L2. This one is L1. This line is L2. Lines 1 and 2. The equation of L1 is given as x plus 2y is equal to 10. And we are also told that line 2 has the coordinates 0, -5. That is also shown. We should also note that these two lines are perpendicular to each other. So let's just indicate that here. So perpendicular here means at 90 degrees or at right angles. So our first task is to express the equation of L1 in the form y is equal to mx plus c, which is one general form of the equation for a straight line. So let's write, if x plus 2y is equal to 10, then we can write as 2y is equal to 10 minus x. Therefore, y is equal to 10 over 2 minus x over 2, which is the same as 5 minus x over 2. So y can be written as 5 minus x over 2. So we could write that here. Also the same as 5 minus x over 2. The same equation, simply a different form. Part 2 of the question is asking, what is the gradient of L1? Well, we know this refers to line 1, also called L1. So the gradient is the coefficient of the x term. So if we call the gradient m 1, then we know that that is equal to negative 1 over 2. Okay, so now we need to determine the equation of line 2. So let us look and see what we have. So let's write the general equation for line 2. Line 2 has the equation y is equal to mx plus c. This is for line 2. That's a general equation. We already have some information about line 2 because we are told that it intersects the y-axis at 0, negative 5. Therefore, we know that c is equal to negative 5 for line 2 because this is the y-intercept. It's equal to negative 5. So we can write as y is equal to mx minus 5. That's part of our equation. We now need to determine m. Now let m2 be the gradient of line 2. Then, because lines 1 and 2 are perpendicular to each other, then m2 will be equal to the negative inverse of the gradient of line 1, which is equal to negative 1 over negative a half, or simply 2. So m2 is equal to 2, and we can rewrite the equation for line 2 as y is equal to 2x minus 5. So this is our equation for line 2. Let's move on to the B part of question 4. So here we're given two functions, f of x and g of x. First, we need to determine what f of 9 is, where f of 9 is simply replacing the values of x in the function f of x with 9. So let's write that will be equal to 1/3 the value of x in the function, which is 9, plus 4. Therefore, this is equal to 7. Part 2 is asking us to find the value of f of g of negative 3. Now, all we're doing is finding f of what is inside the bracket, which is g of negative 3. So first, find g of negative 3. So we're going to now use the function g of x, and we're going to replace x with negative 3. So we can write as g of negative 3 is equal to 3 times negative 3 over negative 3 plus 1, and that is equal to negative 9 over negative 2, which is simply equal to 9 over 2. The negative signs would cancel. So we have a value for g of negative 3 as 9 over 2. So we can go back here and simply write f of g of negative 3 is essentially the same as f of 9 over 2. So replace x with 9 over 2 in f of x. So let's write. So f of 9 over 2 is equal to 1/3 of 9 over 2 plus 4, and that is equal to 11 over 2. Part 3, the question says if g of x is equal to 5 over 2, what is x? Well, we know that g of x, the function, is equal to 3x over x plus 1. So if g of x is equal to 5 over 2, we can replace here as 5 over 2 is equal to 3x over x plus 1, and then solve for x. And that would be equal to, let's just make some space right here. So we can write if 5 over 2 is equal to 3x over x plus 1, we can simply start by cross multiplying to get 5 times x plus 1 is equal to 2 times 3x. Therefore, 5x plus 5 is equal to 6x. And therefore, if I take this x across, I'll have 5 is equal to 6x minus 5x. And therefore, 5 is equal to x, or x is equal to 5. Okay, let's move on to question number 5. Question number 5, a statistics question, is saying 100 students were surveyed on the amount of money they spent on data for their cell phones during a week. I'm expecting that students at this point would have a copy of the past paper so we could do this together. So here we have a data set of 100 students, and what we're shown here is the range of money spent on their cell phone during a particular week. So for example, 7 students would spend between $50 and $60, 11 students would spend between $60 and $70, 31 between $70 and $80, and so on. So here we have calculated the midpoint of this class, 50 and 60, midpoint is 55. That's all that this column is. The first question is asking us to find the modal class of the amount of money spent. This should not present a challenge because the modal class simply is a class which represents the highest number of students. So that would be represented by this class. Highest number of students 31, and this is a modal class, so we could write 70 is less than x is less than equal to 80. So that's our modal class. Part 2 is asking us to find the mean amount of money spent, giving our answer correct to 2 decimal places. So recall that the mean can be found as the sum of f times x over the sum of f. This simply means I am going to take the number of students, which is a frequency, and multiply by the midpoint, which is my x, and then divide by the sum of the frequencies, which if I add all of these together, I'll get 100. So first thing we do is multiply 7 by 55 plus 11 by 65 plus 31 by 75 plus 29 by 85. The last one is 22 by 95. All of that is over the sum of all the frequencies, which is 100. And that works out to be 79.8 or $79.80. Next part of the question reads, Damien reports that the median amount spent is $84. Explain why Damien's report could be correct. So in essence, we are being asked to determine the median amount spent, or an approximate value for the median amount spent. Now, whenever you're asked to find the median amount spent, you will need to introduce a new column called the cumulative frequency column. And I suspect that you all know how to calculate the cumulative frequency. Here I have the cumulative frequency column in green. We will need that information in a little while. So the median amount spent depends on whether we have an even number of students or an odd number of students. In this case, we have an even number of students because there are 100 students. And therefore, the median amount is the average of the amount spent by the 50th and the 51st student. Where is the 50th student? Well, here we have the first 7 ranked student, the next 18th ranked student, up to the 49th ranked student. So the 50th student is actually in this class. So is the 51st student, because all students between 50 and 78 are in this class. So both the 50th and the 51st students fall in this class, which means they spend between $80 and $90. So the median amount of money spent is between $80 and $90. The midpoint is 85, and therefore if Damien concludes that the median is $84, then he is likely to be correct. So we can write the median is between $80 and $90, which has a midpoint of $85, and so an $84 finding is likely to be the correct value. Okay, so let's move on to 5b. 5b is a simple table that is almost intuitive to complete. We're asked to fill out the blank spaces in the table. So here we have totals on the right, totals at the bottom. So 15 plus blank space equal 23. So if this value is unknown, 15 plus, and we would expect this to be 8, is equal to 23. You could also write 8 plus 18 plus 26, the total would be 52. We could also write 15 plus this number plus 14 is equal to 48. So this number is 19. And of course, similarly, 23 plus this value plus 40 is equal to 100. This works out to be 37. So pretty straightforward, pretty intuitive. So that's part 1 to complete the table. Part 2 says if a student is selected at random, what is the probability that he or she was being driven to school on that day? So students, some of them walk, some of them cycle, and some of them drive or are driven. So what we can conclude is that the probability that a student drove to school or was driven to school is the number of all students that drive to school over the population. So the probability of driven is equal to the number to driven over total students. So that is equal to 40 over 100. This is just a relative frequency, which is equal to 4 over 10, or we could write as 2 over 5. This is part 2. So part 3 of the question reads as follows. One of the girls is selected at random. What is the probability that she did not cycle to school? So let's just write what is the probability that she did not cycle. So we're talking about one of the girls and the probability that she did not cycle. And if you think about it, the probability that she did not cycle is the same as the probability that she either walked or was driven. And those two numbers are here. So number of girls that walked plus number of girls that were driven over 100. So that's equal to number of girls who walked is 8 plus 26. Number of girls who were driven or drove over 100. That is equal to 34 over 100, which is equal to 17 over 50. Let's move on to question 6a. What is called a trough, which is really just a box used to feed animals. The box is 5 cm thick. The dimensions length by width by height are shown. So we need to show that the internal capacity, and that's the same as volume, is equal to 8091000 cubic centimeters or centimeter cube. So we need to show this. And we're talking about the internal volume, which means the thickness is going to determine the difference between the internal and the external volume. So let us just note that the internal height, well, we have 160 as its full height, but we know that at least 5 cm is taken up at the bottom because of the thickness. So it's going to be 160 minus 5 or equal to 155. We also note that the internal length is equal to, and here's the length, 300, but there's 5 cm taken up on this side, 5 cm taken up on this side. So it is 10 cm less than this. So it is 300 minus 10, and that's equal to 290 centimeters. And the internal width is equal to, here we have 190 as the width, but 5 cm taken up on one side, 5 cm. So we're losing 10 cm on the width. So it's equal to 190 minus 10 is equal to 180 cm. And therefore we have the internal dimensions, so we can find the internal volume. So internal volume is equal to 155 times 290 times 180, and that is exactly equal to 8,091,000 cm cube. That's part 1. Part 2 is asking us to find the volume of wood needed to make the trough, or the box if you like. So now we merely need to recognize that volume of wood is equal to external volume, and you subtract the internal volume. So we have the external volume are the raw dimensions that you have here. So let's write external volume is equal to 300 times 190 times 160. And that is equal to 9,120,000 centimeters cubed. So volume of wood is equal to 9,120,000. You subtract the internal volume, which is 8,091,000, and the volume of wood works out to be 1,029,000 centimeters cubed. So this is the volume of wood needed. Now part C says the farmer decides to paint the inside of the box. Given that 1 gallon of paint can cover 208,000 centimeter cube of surface area, so we are to determine the total amount of paint in liters needed to paint the inside of the trough. And we're also given that 1 gallon is approximately equal to 3.79 liters. Okay, so we're given those two bits of information. So the first thing we need to do is to calculate the internal surface area of the trough. So we need to find the internal surface area. So let's just label our trough or our box. This is side A, and we have 2 because we have another A on that side. This is side B, and we also have the same dimensions on this side. And of course we have the bottom of the trough. So let us find the surface area of the trough. Remember, we're looking on the internal dimensions, so it is the internal dimensions we're going to be using, and recall we have them over here. So side A, the internal length is 290 and internal height is 155, but we have 2 A's. We have one at the front, one at the back, so we have 2 of those. So the surface area for side A is equal to that, and that works out to be 89,900 centimeters squared. We're talking about square areas, surface area. So the surface area for side B, internal dimensions of side B, that's 190 minus 10, which is 180, times the height of 155. We have 2 of those as well, so that works out to be 55,800 centimeters squared. And the bottom of the trough is equal to the internal length multiplied by the internal width, which is 290 times 180, and there's only one of those, so that is simply equal to 52,200 centimeters squared. When we add all of these, we get 197,900 centimeters squared as my surface area. That's the surface area of the entire inside of the trough. So let's make some more room here for us. So we now have the total surface area, but we know that 1 gallon of paint can paint 280,000. So let's divide here. So gallons needed is equal to 197,900 over 280,000. And that is less than a gallon. That's 0.71 gallons. And since we know that liters is equal to 3.79 times gallons, which is 0.71, we know that number of liters required is equal to 2.68 liters of paint needed. So let's just highlight the key number here. So in essence, Farmer Brown needs 2.68 liters of paint if he plans to coat internal surface area of his trough. Let's move on to question number 7. So as usual, the first 3 figures, figures 1, figures 2, and figures 3 are given, and we are asked to reproduce the 4th figure, which is shown here. A simple reproduction, nothing too magical about this one. So that's the first part of the exercise. Part B of the exercise is to examine this table carefully and study the pattern and then answer the questions. All the questions are shown with a question mark. So we are to fill in this table based on our analysis of the pattern represented by the numbers in the table. So what we're being told is that for figure 1, and we call the figures n, so n is equal to 1, n is equal to 2, n is equal to 3, etc. So when n is equal to 1, we have 6 lines and the perimeter is 5. When n is equal to 2, we have 11 lines, the perimeter is 11, and we have a third bit of information. When n is equal to 3, it moves to 16. So is there a pattern here? Let's see the difference between these two. Difference between 11 and 6 is 5. Difference between 11 and 16 is 5. So clearly we are going up at a rate of 5 for the lines. So if we're going up at a rate of 5 for the lines, then we could form an equation with N and L to find a formula that allows us to predict what the lines will be for any figure N. I like to use a little trick that I know, which is simply to step back by the rate that it is growing. So if I step back by 5, then I would be down to 1. So I know this is the equivalent of my intercept, if you like. So I could write this equation as lines is equal to 5n, that's a rate it's increasing, plus 1. That's my starting point. I could do similarly for the perimeter. The perimeter is increasing by 3 in the first instance. 8 plus 3 is equal to 11. So it's also going up by 3. And if I were to step back by 3, then I would get 2 here. I mean, we can do this many different ways. I'm just making the point that I've found this to be faster and it gives the same answer. So I could write P is equal to, P for the perimeter is equal to 3n plus 2. So I have two equations describing the lines and the perimeter. So here I have an equation, or two equations rather, that describes the number of lines and the perimeter. So I could apply the equations wherever I see n. So here I have n is equal to 5, number of lines. When n is equal to 5, I know that L, let's write the equation here, L is equal to 5n plus 1. So I could write number of lines when n is equal to 5 is equal to 5 times n, which is 5 plus 1, which is equal to 26. And over here I could write my equation, which I know that P is equal to 3n plus 2. I could write when n is equal to 5, I have perimeter is equal to 3 times 5 plus 2, which is equal to 17. Here we have 66 as the number of lines, so I could write 66 is equal to 5n plus 1, and I could solve for n. So if 66 is equal to 5n plus 1, then 66 minus 1 is equal to 5n, and therefore n is equal to 65 over 5, which is equal to 13. So here n would be 13, and over here I could simply write that if n is 13, then P is equal to 3 times 13 plus 2. So we could write as 3 times 13 plus 2, which is equal to 41. And of course, they're asking for equations that describe the length and the perimeter in terms of n, and we have found that already. I hope you found that useful, because this is how you get through these problems quickly and accurately. Okay, so there is a part C to this question. Part C says, write a simplified expression in terms of n for the difference between lines and perimeter. So that difference is described as D is equal to lines minus perimeter. So what we have is L minus P, where L is equal to 5n plus 1, and we're going to subtract P, which is 3n plus 2. So let's simplify. So it's 5n minus 3n plus 1 minus 2, which is equal to 2n minus 1. So that's a simplified expression for the difference. Okay, so in section 2, question number 8, here we have a decision-making problem, and it reads as follows. Marla buys two types of phones. She buys B phones costing $60 each, and she buys C phones costing $80 each. Now, there are two conditions that she must observe. The first condition is that she only has $1,200 to spend on phones. And the second condition is that B phones should be greater than or equal to C phones. So how do we want to think about this? So let X be the quantity of B phones purchased and Y be the quantity of C phones purchased. So in this case, the total cost for B phones would be $60X, and the total cost for C phones would be $80Y. So the total cost then for phones would be 60X plus 80Y. That would be how much money she's going to spend on phones. but based on her first condition, she only has $1,200. So she could spend a maximum of $1,200 on phones. So how should we represent this? We could say that 60x plus 80y is less than or equal to 1,200. And for condition number 2, B phones, which is represented by x, should be greater than or equal to C phones. So we could write this as x is greater than or equal to y. Or we could simply rewrite that to allow y to be the subject. Y is less than or equal to x. These are the same equations, just represented in a different way. So we have two inequations. We have these as inequations because they have a less than or equal to sign. And we would now like to represent this information on a graph. So how do we go about doing this? So first, let us rewrite equation 1 using an equal sign. So let's take the first condition and write as 60x plus 80y is equal to 1,200. Why have we replaced this less than or equal to sign with an equal sign? Because this is going to be a line on our graph, and then the region below that line would be represented by the inequality. We will demonstrate that soon, but if you're having difficulty understanding what I just said, we do have a lesson on graphing inequations on our website. Please go ahead and take a look. So that's our first equation. The second equation would be y is equal to x, and we could represent that line on the graph as well. The y is less than or equal to x would be represented by the area or the region below that line. So let us first graph these two equations. So for equation 1, let's just rewrite. So if 60x plus 80y is equal to 1,200, we could factor this equation and simplify it. So we divide by 10, we would get, and then we could take a further factor of 2 to get, and we now have 3x plus 4y is equal to 60. So let us recognize that this is a linear equation, which means it is a straight line. So to draw a line, all I need are 2 points. So the first point would be to let x be equal to 0 and find the corresponding value of y. So if I let x be equal to 0, then this would be equal to 3 times 0 plus 4 times y. And that would be equal to 60. Therefore, y would be equal to 60 over 4, which is equal to 15. So my coordinates for the first point are 0, 15. That's my first point. Let's put that point on our graph. So when x is equal to 0, y is equal to 15, this is this point on the graph. Point 2, I would similarly let y be equal to 0 and find the corresponding value for x. So if y is equal to 0, then from my equation, I would have 3 times x plus 4 times 0 be equal to 60, and therefore x would be equal to 20. So my second point, or point number 2, would be 20, 0. Why am I finding these 2 points? Because all I need are 2 points to draw a straight line. So I'm conveniently choosing x and y as 0 in order to quickly determine the other points. So my second point, point number 2, will be located at 20, 0, which would be here. So I merely need to connect those 2 points. So there we have our first line, and the equation of this line is 60x plus 80y is equal to 1,200, which we had simplified to give 3x plus 4y is equal to 60. So that's the equation of that line. So in order to represent the inequation or the inequality for this equation, that would be represented by everything that falls below this line. So we have several values of x and y that are represented by the inequation. It falls below that line. Let's go ahead and draw line number 2, which is this one. Y is equal to x. Similarly, we will choose 2 points. The first point I will choose is when x is equal to 0. So I can immediately see that if x is equal to 0, y is equal to 0. So point 1, I'm choosing conveniently in order to get my 2 points quickly. So point 1, when x is equal to 0, y is equal to 0. So my first point would be here. And secondly, my point number 2, I can choose any point. I will choose conveniently x is equal to 10. So I am choosing this. You could choose any point you like. All I need are 2, and I'm choosing the first value for x as 10. And when x is equal to 10, if y is equal to x, then y would also be equal to 10. So I could plot 10 and 10 on my graph. This would actually be this point here. Remember, these are just 2 convenient points that I'm choosing. And then I will connect those 2 points to get my line. And there you have it. I have my second point, which is represented by the equation y is equal to x. And similarly, everything that falls below this line would be represented by the inequality or the inequation y is less than or equal to x. So now that I have these 2 lines, I could go ahead to identify the region that is represented by these 2 lines. Now, what does that region represent? Let's call it R. What does that region represent? That region represents all values of x and y that satisfy these 2 inequations, equation 1 and 2. So how do I identify this region? I will simply look for where the boundary is closed, and immediately I see that everything below this line and everything below that line, so my region would actually be represented as shown in green. Now you may want to recognize at this point if phones cannot be negative. In other words, if I cannot purchase a negative phone, then my region would simply be bounded also by the x-axis. But that was not explicitly stated, so we will recognize that all values below these 2 lines are part of the inequation. So here's the region identified, and now we need to go on to the next part of the question. If we want to call the total number of phones t, then we could say if t is representing the total number of phones, which is equal to x plus y. So what is the largest amount of phones that can be purchased? So in order to find this, you would go to your graph and you would identify the vertices of your boundary. And let me identify it here. So I'd call this point 1, point 2, and point 3. The number of phones represented by point 1. So at point 1 or at vertex 1, we could refer to this as t1, and that is equal to the values at x and y at that point. So that's equal to 0 plus 0, 0. At point 2, we'll call this t2. So at t2, the coordinates are 8.5b phones and 8.5c phones. A little impractical since we will not be able to purchase half of a phone. So we will take the next lower number. So we will take 8b phones and 8c phones, which is represented by this point. So let's write for point 2 first. So which would be 8b phones and 8c phones, which would be a total of 16 phones. And at point 3, we would have 20b phones, no c phones, and that would be equal to a total of 20 phones, which is clearly the largest possible number of phones that I can purchase as per the question. Let's move on to 8b. Part B of the question is simply to plot a quadratic equation, and a table is produced. The table is shown on the past paper, as you will notice. And the equation that we are describing is y is equal to x squared plus x minus 4. So the graph is shown here, and part 1 is to draw the graph. Here we have drawn the graph. Part 2 is asking to write down the maximum or minimum value of the function. This is a function. It's described by the equation x squared plus x minus 4. And the minimum value of the function, or the lowest value of the function, is all the way down here, and it is read directly from the graph is equal to negative 4.25. And part 3 says, using a ruler, draw the axis of symmetry on the graph. What do we mean by the axis of symmetry? I would like you to imagine the axis of symmetry as a mirror line. It is the axis about which this function is symmetrical. We can see from the graph that that line, that axis of symmetry, which I also am referring to as your mirror line, just to give you an idea how you could view this. So we could write axis of symmetry, x is equal to negative 0.5. So the axis of symmetry is the point around which this graph is symmetrical, or it is equivalent to your mirror line, and it is found that x is equal to negative 0.5. So let's move on to question number 9. Question number 9 is something that pops up on the paper almost every year. It's circle geometry, which some students find intimidating, but like I say to my students, it's just about recognizing that a few rules exist that relate to circle geometry. Once you know those rules, the rest is downhill. So let's take a dive in and see how we would solve a question like this. So question 9, as you can see on the past paper, is a circle with several lines in and outside of the circle. What I've actually done is I've unpacked this circle to show you just exactly what you need to solve each portion of the problem. And this is the approach I'd like you to take. So simply take the portion that you're going to be using at the time that you need it. So for the first question, it says find angle ECD, which is this angle highlighted here. You're also told that CD and AB are parallel. So any line crossing those parallel lines will form alternate angles. So AEC must be equal to ECD, which is equal to 68 degrees, because alternate angles are equal. So our first angle is 68 degrees. Second part of the question, we are asked to find CEG. So this is this angle here. Okay, so what I wanted to make a note of immediately is that O to E is the radius of that circle and AB is a tangent. So AB is a tangent, and angles between tangent and radius is 90 degrees. So I've highlighted that here in red, and therefore if I know that a part of that angle is 68 degrees, then this is simply the complement of that angle. So CEG must then be equal to 90 degrees minus 68 degrees, which is equal to 22 degrees. So the last part of this question is to find the angle at G, which is this angle here. So the approach we're going to take is as follows. We're going to determine the angle at C, which is X. Then we're going to determine the angle Y. And then we're going to also find angle Z. Why are we taking this approach? We know that angles in triangle G, C, F add to 180 degrees. And therefore, by finding X and Y, we will simply do a subtraction to determine angle G. So let us proceed first to find angle X. And in order to do this, we'll apply a theorem from circle geometry that will help us. So let's just branch over to this little drawing on the side here, where we have a circle and a single triangle. And in this case, triangle, let's call this point C. Triangle ACB is such that AOB is the diameter of the circle, and from the theorem that angles subtended from a diameter at the circumference are equal to 90 degrees, then it means that the angle at C, which is this angle that I've highlighted in red, is really 90 degrees. If we extend that argument over to our drawing, we can see that the angle at C and the angle at F are both 90 degrees as highlighted in red, because GOE is the diameter of that circle. So if the angle at C is 90 degrees, then it means that X plus 68 degrees is equal to 90. Therefore, X is equal to 22 degrees. So let's put that here. So that's the first angle. X is equal to 22 degrees. So now we proceed to find angle Y, but in order to find angle Y, we first need to know angle Z. Now if you notice that CF FD is a straight line, and based on our knowledge that angles on a straight line add to 180, it means that 106 plus Z add to 180. So we could write Z plus 106 is equal to 180 degrees, and therefore angle Z is equal to 74 degrees. So we could write this here as well. So we have found two angles, and now it is very simple to recognize that Y plus 74 degrees add to 90 degrees. So we could write Y plus 74 degrees are equal to 90 degrees, and therefore Y is equal to 16 degrees. So we could put 16 degrees here for Y, and now we have enough information to find angle G, because we know that angles in a triangle add to 180 degrees. Therefore 22 plus 16 plus the unknown angle which we're asked to find, which is the angle at G. Let's call this CGF, which is what we're asked to find. CGF, that adds to 180 degrees. Therefore CGF, which is the angle we're interested in finding, is equal to 180 degrees minus 22 degrees plus 16 degrees, and that is equal to 142 degrees. Okay, so for question 9b, which is a bearings question, here we have a harbor H and the bearings of two ships Q and R. So Q is a vessel and R is also another vessel on the bearings shown. So what we're seeing here is that the ship Q is on a bearing, and remember your bearing is read from north, which is here, in a clockwise direction always. So between the north and the bearing Q from H is 69 degrees, and that is given. And you're also given the bearing of ship R as 151 degrees, as shown here as well. The distances of H to Q is 175, and from H to R is 242 kilometers, and all is displayed on this diagram. Now you are asked to find in the first instance the distance QR. Now this should not present a problem because you're given a triangle HQR, you're given two sides, and you know the included angle shown in blue. Because the bearing of R is 151 and the bearing of Q is 69, then this internal angle here is called that as this angle here theta. That's the internal angle, or the included angle, is simply equal to 151 minus 69, and that is equal to 82 degrees. So we could stick that in there real quickly. So this angle is 82 degrees. Okay, so now that we have that angle, from what you've learned, we know that if you have a triangle and you have two sides and an included angle, and included here simply means the angle between the two sides, then we apply the cosine rule in order to find the third side. So we apply our cosine rule, which says that if this distance, let's call this distance from Q to R, let's call this distance x, we like to use x, then we could write using the cosine rule as x squared is equal to 175 squared plus 242 squared minus 2 times 175 times 242 times the cosine of 82 degrees. I expect you would have done this many times, so I'm just going over the familiar. And this gives x as 282 kilometers. So that's the first part of the question, or rather the second part. The first part is to reproduce this drawing here, this nice colorful drawing here. So part 3 of the question is asking us to determine how far due south is ship R of the harbor H. So let's try to unpack all of that. So here's ship R, and here's south, and here's harbor H. So the question is asking how far due south, which means if I'm actually measuring this length, how far is ship H from the harbor? It's merely asking me to find the component of 242 kilometers, which is going straight down or in a southerly direction. So between R and a point on the south, then this distance from H, let's call this point, this is merely defining south, let's call this point K, then this distance HK is what they're interested in finding. So we would need to know this angle, which we do because this is 151. So let's write this angle, let's call it phi. So we could say phi, that angle, is equal to 180 minus 151, which is equal to 29 degrees. So we could write here as 29 degrees. Okay, so we have phi as 29 degrees. Of course, this we have projected as a right angle. So let's call this point small r. So we could say then r, which is what we are required to find in kilometers, if we relate it to the cosine of the angle, we could say cosine of 29 degrees is equal to r, which is adjacent, over 242. So let's write cosine of 29 degrees is equal to r over 242 kilometers. Therefore, r is equal to 242 times the cosine of 29 degrees, and that is equal to 212 kilometers. Let's move on to question 10. So we're given two matrices and we're asked to determine the product of these two matrices. So let me give these matrices names. So let me call this matrix A, I'll call this matrix B, and I will call the product matrix C. This is just for convenience because we will refer to those names later. So we're asked to determine the product of matrix AB, and I have already determined the matrix AB is equal to C. So how did I do that? Well, the first thing I note is that I'm going to multiply two matrices, so I merely need to make sure that the rows on one matrix is equal to the columns on the other matrix, and I'll be fine. So here I have two rows, number of elements in the rows are 2, number of elements in my column are 2, so I can multiply. Let's call this C11. I have already obtained C11 to be equal to 10. So if C11 is equal to 10, I have already obtained that. How did I arrive at this answer? So let's show how to multiply a few elements, and then we could conclude that we all know how to do this. So what I like to do is first recognize that to multiply these two matrices, I would multiply row 1 by column 1 to get C11, which is exactly what it means. C11 is obtained by multiplying row 1 by column 1. That's row 1 of matrix A by column 1 of matrix B. And my answer is 10. So how do I do this? So I would have C11 is equal to 5 times 2 plus 4 times 0, which is equal to 10. And this is how I got this 10. Now, I'm doing all of this for a reason, because I'd like to show you something that I have found useful over time, because it is so easy to make an error when you're doing matrix multiplication. I like to use a technique called the cover-up, C-O-V-E-R, a cover-up technique. And here's how that works. And we will use C12. So we know that C12 is equal to 17. So how did we get that? So this is multiplying the first row by the second column. So here's what I would do. I would recognize that I am multiplying the first row by the second column. And what I would do, I would hide or cover up the elements that I'm not using. I've actually used my fingers or a ruler or a pencil or something to hide any element that's not going to be involved in my multiplication. So I am using row 1 and column 2. So I'm going to hide everything that I'm not using. So this is row 2, this is column 1, column 3. So I hide those, I cover them up. So now I can easily see that C12 will be equal to 5 times 1 plus 4 times 3, which is 5, plus 12, which is equal to 17, which is the answer I'm looking for. So I just want to show that to you. If it helps, then more power to you. If not, then happy hunting. I found this to be extremely useful under very stressful conditions like examinations, and you want to reduce your risk of making errors, simple arithmetic errors. So I won't be doing much more on matrix multiplication. I merely want to show this to you. And I would use a similar method to continue to find C13 and the rest of the other elements. Alright, so here you're asked to state why the two matrices can be multiplied. Here's matrix A. The number of elements in the row is 2. 1, 2. These are the number of elements in the row. So let's identify the row. These are the number of elements in the row. Element number 1, element number 2. Here's matrix B. These are the number of elements in the column. So it's a row of one matrix and the column of the other matrix need to have the same number of elements. Once they have the same number of elements, matrix multiplication is possible. Okay, so let's move on to the final part of this matrix exercise. So in 10b, we're asked to find the inverse of this matrix is equal to the adjoint of the matrix A divided by the determinant of the matrix A, where adjoint of A is simply found by interchanging these two, which means swap them around. So 2 goes here, 5 goes down here, so it's negative 2 and 5, and then you reverse the sign of these non-leading diagonal elements. So this would be negative 4, reverse the sign of this one, it becomes positive 3, and that would be your adjoint matrix. Your determinant is simply found by multiplying the leading diagonal elements, or it's a product of the leading diagonal elements. So it's 5 times negative 2, and you're going to subtract the product of the non-leading elements, which is 4 times negative 3. So that would be 5 times negative 2 is negative 10, and you're going to subtract negative 12. So you'd end up with negative 10 plus 12, and that would be equal to 2. So your final answer, which is your inverse, would be negative 2, negative 4, 3, 5 all over 2, which could be rewritten as a half of negative 2, negative 4, 3, and 5. Okay, so 10C is a question on vectors, and we have an entire lesson on vectors that is available on our website, so please take a look if you would like to master the topic of vectors. We're going to apply the same techniques that we use in the lesson on the website. We're going to apply these here. So here it is. We are given a diagram AOB in which we are given that the vector from O to A, which is written here, is equal to R, and the vector from O to B is given as equal to S. We're also given that CD, the line connecting these 2 points, the midpoint of CD is E, so E is at the midpoint or in the center of CD, and we are given even more information. We're told that from O to C is really 3/4 of the distance O to A. So we could write that easily. We could say that OC is equal to 3/4 of OA. That's what we're really saying. So which means that this section here would be C to A. So we could write all of this up here. We could say O to C is equal to 3/4 of O to A, which by extension would mean that from C to A is really equal to 1/4 of O to A. That's a logical extension. We are similarly given that A to D, which is this distance from A to D, given as a vector or even as a ratio, we're given it as 2/3 of AB. So we're given, so AB is this entire length here, and we're given a portion of it, A to D, as being simply 2/3 of that distance. So this is all familiar territory that we no longer find intimidating because we understand what it is you're saying. It should also mean that D to B, just for argument's sake, D to B would be, if this is 2/3, then this is 1/3 of the total distance A to B. So we have a lot of information, certainly enough for us to get ourselves all started. So first question, let's write it here. Question number 1. Write in terms of R and S an expression for CD. So we're asked to find the vector CD. Now we have already done an in-depth review of why we can apply vectors to geometrical shapes. So please review our video lessons if you would like to learn how to apply these simple principles and strengthen your confidence in this area. Okay, so CD, the vector from C to D, is the first thing you're asked to find. So let's just look. Here we are at C and we want to get to D. We're asked to find that vector. So let's label it. It's called C to D, going in the direction of C to D. So very simply, it means that if I start at C, I must find a path that will allow me to get to D. So I could go from C to A in this direction like that. And then when I get to A, I travel down to D. So C to A plus A to D. So I could write CD is equal to C to A, the vector C to A, plus I'm now at A, so get down to D. So it's adding A to D. So I'm adding vectorially, and it's intuitive. So I want to go from C to D, so I go from C to A, then A to D. Do I have vectors for these two? Yes, I do. Because C to A, I've already shown to be equal to 1/4 of OA, and A to D is equal to 2/3 of A to B. So, do I have enough information to find CD? I have OA, because O to A is given as R. Let's just write that in. It's equal to 1/4 of R is a vector for OA, so it's R, plus 2/3 of AB. Do I have AB? No, I don't. I will have to find it. That's not a problem. So I need to find AB in terms of R and S, or S, whatever it turns out to be. So let's find the vector AB, which is a vector going all the way from A all the way down to B. So if I am at A and I want to get to B, I'm going to find a path to get to B. So I'm going to travel from A to O. So let's just tell you how I'm going to travel. So I'm going to go down this way from A to O. When I get to O, I'm going to travel across to B along OB. So that's what I'm going to be doing. So AB, that's a vector I want, and I'm going to find a path to get from A to B, and I can go from A to O, and I'm going to add vectorially to O to B. Now, do I have A to O? I do not have A to O directly, but I certainly have O to A, and I know that O to A is simply the negative of A to O. So I could write this as negative O to A. That's not a challenge, because this just simply means the same size vector going in the opposite direction. So we can write that as, or rearrange and have O to B minus O to A. That's not also a challenge. All I've done is put O to B on the left and the negative on the right. So O to B is S, O to A is R. So I could write CD equal to 1/4 R plus 2/3 AB, and I now have a value for AB. So I say it's equal to 1/4 of R plus 2/3 of A to B, which is S minus R, and I can now simplify this as follows. Let's expand. So we have that's equal to R over 4 plus 2/3 of S minus 2/3 of R. So I may want to get all of these terms over the same denominator. So let's use a common denominator of 12. So I would have 3R over 12 plus 8S over 12 minus 8R over 12. I can now subtract and add like terms. So I have negative 8R and positive 3R. So that becomes equal to 8 8s over 12 minus 5r over 12, which I can further simplify as 1 over 12 into 8s minus 5r. So that's our value for CD. I would argue that it's a little lengthy, but it's pretty straightforward and intuitive. But this is only if you know exactly what you're doing. I'm saying if you're having some challenges, please review the lessons. We have 3 lessons, which is a complete review of vectors for CSEC level students. Finally, we're asked to find OE, a vector OE. Do we have that vector? Let's draw the vector OE so we could identify it. So that is a vector going from O to E. To get from O, I like to do it like this. To get from O to E, we go from O to C and then C to E. So we could write it's equal to going from O to C. We add that vectorially to the vector C to E. Do we have the vector OC? Yes, we do, because that is equal to 3/4 of the vector OA, where OA is equal to R, so that's equal to 3/4 of R plus CE. CE is half of CD because we have it here already. This is the midpoint, so this is half the length, and therefore it's half of this vector. So a half of this would be a half of this vector, and that is simply equal to 3/4 R plus half times 1/12 is 1/24, so it's 1 over 24 of 8s minus 5r. So let's expand. So we could write as 3/4 of r plus 1 over 24 times 8s minus 1 over 24 times 5r. Let's simplify some more and make some room right here. So we could continue and we could change all denominators to 24 by multiplying this fraction by 6, both the numerator and the denominator. So that's 18 over 24r plus 8s over 24 minus 5r over 24. Now we have the same denominators. We can apply straight addition and subtraction. So 18r minus 5r is equal to 13r over 24 plus 8s over 24. Finally, and after some effort, is equal to 1 over 24 into 13r plus 8s. So let's just highlight that to make sure that we see it clearly. And that is our final value, 1 over 24 and 13r plus 8s. Like I'm saying, it's a little lengthy, but it's just simple arithmetic, taking one step at a time to your destination. Okay, so I think we may be down to our final question, and that's 10D. So let's wrap this up quickly, and we're going to use a purely graphical approach to solve this problem. So in this question, we're asked to find a few vectors. So let's just identify what they are. First, let's identify a few position vectors. Position vectors can be extracted immediately from the coordinates. So OR, the position vector from O to R, is simply 1 unit to the left and 4 units up. So it's equal to -1 and 4. The position vector OQ is simply equal to 5 units to the right, 2 units up. So that's 5, 2. Finally, we are asked to find the magnitude QR, that's a vector, and this simply means we want to find the actual length of the line, and this is how we do this. First, let's find the vector QR. So the vector QR is simply the vector going from Q to R, which is this vector here in this direction. We're going from Q to R, not R to Q, which is quite different. So let's identify it's Q to R, that's a vector. So let's take the horizontal component of that vector. So we're going to start from here and move to the left all the way out to this point. So let's count. We're counting in steps of 2. So that's 1, 2, 3, 4, 5, 6. So we're going to go 6 units to the left. So that's negative 6. And we're going to go 2 units up. So it's going to be negative 6 and 2, positive 2 for up. Now that we have the vector QR, the magnitude of QR, which is written like this, is equal to, we find using Pythagoras, so it's going to be the square root of negative 6 all squared plus 2 all squared, and that is equal to 6.3 units. And that brings us to the end of the CSEC July 2021 math examination. See you next time.